Hello, everybody. Today, I want to present my project about effect of solar ventilation on thermal improvement and energy efficiency of building using fast change materials. This is my Benachir from Morocco, Hassan First University of Stats, École Nationale des Sciences Appliquées. So, this is my plan. Introduction, methodology, results, and conclusion. This is energy with PCM, the creative fast change materials with mechanic solar ventilation and building envelope. So, and this first phase of the project, the main focus was on the design of the building envelope with PCM and mechanic solar ventilation, MSV, are integrated and the overall model the energy consumption related to the specific use of electricity and thermal is taken into account and the annual energy balance. The whole project is modeled under design border and transit. For the climate of Casablanca and Wasl, the results show that the mechanic solar ventilation plus PCM minimize the operating relative humidity of the building envelope, and the mechanic solar ventilation has decreased its average operating temperature by about 2.6 degrees Celsius, reducing the annual consumption for heating and cooling, and eliminate the noise and moisture surface, and created the comfort.
Nahela?
Yes?
Your slides is not changing. You are still on the first slide.
I want to present my logiciel transit.
Okay.
The introduction for logiciel transit and design builder from integrated the solar ventilation, thermostat and photovoltaic and ventilation and sample building, and the multi-zone building for integrated the fashion materials with mechanic solar ventilation. So PCM walled plâtre, plâtre plus PCM plus solar ventilation. So figure 3, 4, and 5 show the evolution of the outside air temperature and the air temperature inside the building envelope, which was incorporating PCM and mechanic solar ventilation, and without PCM and mechanic solar ventilation in summer, and Casablanca and Wasser. The results of the simulation show that the temperature of the outside air 30 degrees Celsius. The temperature of the air without PCM and mechanic solar ventilation vary between 24 and 28 degrees Celsius. And temperature with wall PCM and mechanic solar ventilation has low values compared to that without PCM and mechanic solar ventilation. The temperature with PCM vary between 23 degrees Celsius and 25 degrees Celsius. It was found that the presence of fast change materials with mechanic solar ventilation and the wall decreasing the air temperature by 3.2 degrees Celsius.
Nahela, you are still on the first slide. Your slides are not changing. I can't able to see your any other slide. You are still on the very first slide.
What?
So you are on the first slide. Your slides are not changing.
Ah, okay. Okay, table 1 present the maximum amplitude.
Okay, you're still on the first slide. Yeah, now it's fine.
Okay. The figure presents the temperature with PCM plus mechanic solar ventilation and without mechanic solar ventilation and the PCM. So the fluctuation for temperature for 3 degrees Celsius. This is conclusion for a 3 figure and table. We will pass a monthly cooling consumption of air conditioning with PCM plus mechanic solar ventilation and without PCM and mechanic solar ventilation. The figure presents the cooling and heating. So the comparison of heating and the cooling requirements for the two scenarios shows that the building with PCM and mechanic solar ventilation require less energy for heating and cooling than the building without PCM plus mechanic solar ventilation during all months of the year. During the winter period, the month January has the highest energy consumption during heating. The building without PCM and mechanic solar ventilation consume 140 kilowatts for heating, but the building with PCM and mechanic solar ventilation consume only 100 kilowatts. The month of August has the highest consumption during the cooling season. The air conditioning energy consumption for the building with PCM and August was 24 kilowatts, slightly lower than that without PCM and mechanic solar ventilation consume 52 kilowatts. This is the result. Table 2 present the energy consumption with mechanic solar ventilation and PCM and without PCM and mechanic solar ventilation. With PCM from heating and cooling, 423.5 kilowatts, and without PCM and mechanic solar ventilation, 625.6 kilowatts. Again, the 202 kilowatts, 32.35% for the gain and the reduction from cooling and heating. And from cooling and heating and infiltration and entering the surface the building from PCM and mechanic solar ventilation consume 1,340 kilowatts, and without PCM and mechanic solar ventilation from infiltration consume 1,766.9 kilowatts, gain 25.6%. We will pass a figure 9. Figure 9 presents energy consumption for different amounts of solar ventilation and summer. So you can change the air sulfur from the ventilation. We can heating plus 0.4 ventilation plus natural ventilation. So figure 9 and and 10 show the effects of the amount of ventilation on the heating and cooling energy consumption for the climate zone Casablanca and Wasser. The cooling energy consumption decreases with increasing of mechanic solar ventilation. In general, the greater the amount of ventilation provided, the greater the effect of the PCM on energy saving. However, the effect of the amount of ventilation on energy consumption became when the ventilation was greater than 1.5 AC by hour. The energy consumption decreased and similarly 90% from reduction. And when decreasing the mechanic solar ventilation amount between 0.4 AC by hour and 1.3 AC by hour, the energy consumption decreased in winter 52.5% from reduction. So we take between 0.4 and 1.3 AC by hour and the heating period, and between 1.3 and 2.2 AC by hour and the cooling period, which means that the amount of ventilation also played an important role in reducing energy consumption and created the comfort and fresh air internal surface and maintain the annual demand for heating and cooling, and creating the thermal comfort and inner building envelope. Figure 11 presents thermal discomfort index with mechanic solar ventilation and PCM and without PCM and mechanic solar ventilation. For example, on a guest from discomfort index without PCM reduction 40%, and with PCM 5%. So the lower reduction. Figure 12 presents monthly CO2 concentration with PCM and mechanic solar ventilation and without mechanic solar ventilation and PCM. The comparison of the CO2 concentration for the two scenarios shows that the building with PCM and mechanic solar ventilation requires less CO2 concentration than the building without PCM plus MSV. The reduction of 28% from CO2, and we can recover the quantity from CO2 solar energy and hydrogen, and concluded that the efficiency of the PCM can be improved if the building can be properly ventilated. To realize some of the heat gain during the night, solar mechanic ventilation also increase the airflow locally and improve heat transfer. Similarly, mechanic solar ventilation can be used to some of the heat gain during the night. The mechanic solar ventilation can be one of the most effective measures and minimize under temperature fluctuation and relative humidity, and mode and reduce building energy consumption for HVAC system. HVAC system, heating, ventilation, and cooling, and CO2 concentration, and maintain annual demand for HVAC system, and control the heat exchange airflow with inner and external surface. So the optimum performance electrical and thermical, you can give me the building plus, and created the fresh and comfort space we will respect environmental and use the organic materials. Thanks and see you soon. And thanks for attention.